जो है किसी भी प्रॉब्लम का जो है हम सोल्यूशन निकालते हैं। अब सबसे पहले हम हाइपोथेसिस टेस्टिंग के लिए कोई प्रॉब्लम किस तरह से डिफाइन करें, कोई भी स्टैटिस्टिकल प्रॉब्लम जो है वो किस तरह से क्या होगी, किस तरह से होगी, वो हम आज इस लेक्चर में हम डिस्कस करेंगे। तो सबसे पहले अ, अच्छा अच्छा स्टैटिस्टिकल प्रॉब्लम होती क्या है, अगर हम सबसे पहले डिस्कस करें। स्टैटिस्टिकल प्रॉब्लम अराइजेस व्हेन वी नीड टू एनालाइज डेटा टू मेक इन्फॉर्म्ड डिसीजंस। जब भी हम जो है ना, whenever we were trying to analyze any data, for example, if we want to find out the inferences about any problem regarding any at any hospital, etc., and we want to make the informed decision about that problem. For example, if we want to talk about what is happening, कि कोई बीमारी है, कोई मरीज है, उसके साथ अगर लेट से कोई अनयूजुअल बिहेवियर हो रहा है उसकी बॉडी में, तो हम किस तरह से उसके डेटा को एनालाइज कर सकते हैं किसी भी प्रॉब्लम को, इसे हम कहेंगे स्टैटिस्टिकल प्रॉब्लम। या फिर हम कह सकते हैं कि जी कोई भी वायरस है वो फैल रहा है ना, किसी भी इलाके में, किसी भी रीजन में कोई वायरस अगर फैल रहा है, उसके उसकी ग्रोथ रेट क्या है, वो प्रॉब्लम कितना कितना वो वायरस जो है कितना नुकसान पहुंचा सकता है, या फिर किसी भी कम्युनिटी को किस लेवल तक जो है ना वो प्रॉब्लम क्रिएट कर सकता है। अब ये आपके पास एक किस्म की स्टैटिस्टिकल प्रॉब्लम होती है। इट इन्वॉल्व्स आइडेंटिफाइंग अ रिसर्च क्वेश्चन। इसके अंदर क्या आता है, सबसे पहले आपके पास रिसर्च क्वेश्चन होता है एंड यूजिंग स्टैटिस्टिकल मेथड टू फाइंड द सॉल्यूशन। सबसे पहले आपके पास क्या होगा, रिसर्च क्वेश्चन होगा। व्हाट इज रिसर्च क्वेश्चन? रिसर्च क्वेश्चन आपके पास ऐसा क्वेश्चन होगा जो क्या करेगा, आपको आपको सोचने पे मजबूर करेगा, या आपको बताएगा कि कोई सोल्यूशन आप जो है ना निकालना है। फॉर एग्जांपल, क्या जी मैं कहूँ कि क्या ये मेडिसिन जो है ना ब्लड प्रेशर को लोअर कर सकती है, डाउन कर सकती है? अब ये एक आपके पास एक रिसर्च क्वेश्चन होगा कि जी कोई मेडिसिन बनाई है किसी फार्मा कंपनी ने। अब वो कंपनी उस मेडिसिन को जो है ना रिसर्च करना चाहती है कि आया कि वो प्रॉब्लम काम करेगी या नहीं करेगी, और मेडिसिन काम करेगी या नहीं करेगी। फिर हम क्या करते हैं, उस पर यूजिंग स्टेटिस्टिकल मेथड्स, हम उसको स्टेटिस्टिकल मेथड्स को यूज करके उसका सोल्यूशन फाइंड आउट करते हैं किसी भी प्रॉब्लम का। कोई प्रॉब्लम थी आपके पास स्टैटिस्टिकल प्रॉब्लम के जी कोई भी जो है ना, हमें ये मालूम करना है कि कोई डेटा को एनालाइज करके कोई डिसीजन लेना है हमने किसी भी डिजीज पे या किसी भी मेडिसिन पे। अब उसको हम क्या करते हैं, एक रिसर्च क्वेश्चन बनाते हैं। उसके अंदर रिसर्च क्वेश्चन क्या होगा, वो ये बताएगा कि जी इस प्रॉब्लम का जो है ना मेन सोल्यूशन आप निकालना क्या चाहते हो। फिर आप स्टैटिस्टिकल मेथड अप्लाई करके उसके सोल्यूशन फाइंड आउट करोगे। फिर आप हाइपोथेसिस टेस्टिंग अप्लाई करेंगे। हाइपोथेसिस टेस्टिंग इज यूज्ड टू डिटरमाइन इफ रिजल्ट्स आर स्टैटिस्टिकली सिग्निफिकेंट और नॉट। हाइपोथेसिस टेस्टिंग जो आपके पास होगी वो किस लिए अप्लाई होगी, वो ये बताएगी कि जी जो आपने रिजल्ट डिफाइन किए हैं, जो आपने रिजल्ट डिटरमाइन किए हैं, वो स्टैटिस्टिकली सिग्निफिकेंट है या नहीं है। यानी वो कहीं पे गट फीलिंग तो नहीं है, कोई आपके पास डेटा ड्रिवन डिसीजन है, या विदाउट डेटा ड्रिवन डिसीजन जो है ना आप उसके जो है ना किसी भी स्टैटिस्टिकल प्रॉब्लम को एनालाइज कर रहे हो। तो ये सबसे पहले आपके पास हाइपोथेसिस टेस्टिंग में आता है। इसकी एग्जांपल क्या है आपके पास स्टैटिस्टिकल प्रॉब्लम की। अ कंपनी वांट्स टू नो, कि कोई कंपनी चाहती है, वांट टू नो इफ अ न्यू प्रोडक्ट पैकेजिंग इंक्रीजेस सेल्स और नॉट। कोई कंपनी चाहती है कि जी एक नया प्रोडक्ट वो लॉन्च करना चाह रही है, प्रोडक्ट की पैकेजिंग को चेंज करना चाह रही है। क्या प्रोडक्ट की पैकेजिंग चेंज करने से क्या सेल्स बढ़ती है नहीं बढ़ती, क्या इनकम बढ़ती है नहीं बढ़ती, रेवेन्यू बढ़ता है नहीं बढ़ता? ये एक किस्म की स्टैटिस्टिकल प्रॉब्लम है आपके पास। या बिल्कुल इसी तरह से कहते हैं कि जी अगर लेट से फॉर एग्जांपल किसी ब्लड प्रेशर को जो है ना, किसी बंदे को जो है ना लेट से ब्लड प्रेशर का इशू है, और उसको ब्लड प्रेशर को डाउन करना चाहते हैं हम, तो क्या कोई एक मेडिसिन जो वो कंपनी लॉन्च करना चाह रही है, क्या वो उस ब्लड प्रेशर को डाउन करेगी या नहीं करेगी? ये आपके पास एक स्टैटिस्टिकल प्रॉब्लम हो जाती है आपके पास। अच्छा, इंपॉर्टेंस क्या होती है आपके पास आइडेंटिफाइंग किसी भी स्टैटिस्टिकल प्रॉब्लम को? सबसे पहले आपने प्रॉब्लम को आइडेंटिफाई करना है, स्टैटिस्टिकल प्रॉब्लम को। उसकी उसकी इंपॉर्टेंस क्या है, जब तक आपको स्टैटिस्टिकल प्रॉब्लम आपको पता नहीं होगी, आप आइडेंटिफाई नहीं करेंगे, तो यू वुडंट बी एबल टू टेक द इन्फॉर्म्ड डिसीजंस। सबसे पहले आपके पास जो स्टैटिस्टिकल प्रॉब्लम की आइडेंटिफिकेशन है वो आपको हेल्प करती है इन मेकिंग द डेटा ड्रिवन डिसीजंस। जब आप डेटा ड्रिवन डिसीजन लेते हैं ना, यानी जब आपको पता होता है कि नंबर आपके सामने होते हैं कि जी अच्छा अगर जो है ना सेल्स बढ़ रही है, नंबर ऑफ सेल्स पर मंथ बढ़ रही है, और आप फिर कहेंगे हाँ जी ये डेटा ड्रिवन डिसीजन है। और अगर आप ऐसे ही कहते हैं कि नहीं जी अगर ये बढ़ाएंगे तो ये हो जाएगा, ये करेंगे तो ये हो जाएगा, डेटा की बेसिस पे आप डिसीजन नहीं लेंगे, तो उसको हम कहते हैं कि वो गट फीलिंग्स है आपके पास, दैट आर नॉट द डेटा ड्रिवन डिसीजन। तो कभी भी किसी स्टैटिस्टिकल प्रॉब्लम को आप आइडेंटिफाई करते हो, उसकी आपकी हेल्प, उससे आपको उसकी इंपॉर्टेंस क्या है कि वो आपको हेल्प आउट करता है डेटा ड्रिवन डिसीजन में। इट इंश्योर्स द रिलायबिलिटी एंड एक्यूरेसी इन रिसर्च। जब आप किसी स्टैटिस्टिकल प्रॉब्लम को आइडेंटिफाई करते हो, डेटा ड्रिवन डिसीजन लेते हो, तो वो आपको हेल्प आउट करती है कि आपके जो रिसर्च कर रहे हैं आप, उसकी जो एक्यूरेसी है, उसको जो है ना वो उसकी रिलायबिलिटी को एक्यूरेट करती है, उसकी एक्यूरेसी को जो है ना आपके पास वो क्या करती है, फाइंड आउट करती है कि जी वाकई एक्यूरेट है या नहीं है जो आप प्रॉब्लम डील कर रहे हो। इट अवॉइड्स मिसलीडिंग कंक्लूजन्स। जो आप कंक्लूजन ले रहे होते हैं उससे मिसलीडिंग जो होती है आपके पास, कभी कभी आप क्या करते हैं कि जी असल मसला कुछ और होता है और आप अपने आप को चेंज कर देते हैं किसी दूसरे मसले की तरफ। तो जो स्टैटिस्टिकल प्रॉब्लम की एनालिसिस है वो उससे भी आपको अवॉइड करती है। और इनकरेक्ट assumptions, it avoids from the incorrect assumptions. If you would be able to make the decisions, data driven decisions, you are not supposed to take the incorrect assumptions, because you are data driven. Your decisions are data driven and your conclusions are data driven. For example, if we talk about an example about the identifying a statistical problem, a doctor testing whether a new treatment is effective or not. This would be a kind of an example of a, for example, statistical problem. A factory analyzing if machine upgrades reduce defects. If you are, what we can say, upgrading any machine that was used in the factory. For example, if you are upgrading the machine, whether it reduces the defects or not, or whether the defects are increasing or decreasing. It would be a kind of an example of a statistical problem. Okay, the three would be a school measuring if online learning improves the student performance or not. It would also be a kind of a statistical problem. Okay, what are the types of statistical problems? So there are a bunch of problems for what we can say types of statistical problem. Number one out of which is descriptive problem. Okay, in descriptive problem, we only summarize the data using the measures like mean and standard deviation. For example, we studied in the biostatistic one. In descriptive problem, there would be only the summarizing of the data, and it would include finding out the mean, mode, median, and standard deviation or dispersion of the data. Number two is the inferential problem. In the inferential problems, a statistical problem, we make the predictions or conclusions about a population using sample data. Okay, in inferential problems, we take a sample out of the population and then we make the predictions about the data, or we make the conclusions about the data about the population, whatever is in our interest. The number three is the relationship problems. In this, we investigate between correlations between two or more variables. This is called the relational problem. So, okay, for example, if we talk about whether increasing the temperature increases the sales of ice cream or not, this is a kind of relational problem. Number one is the descriptive problem, in which we only summarize the data. We take the measures, we take the mean, we take the mode, we take the median, and we take the standard deviation, dispersion, etc. But at number two, we take the inferential problems. We make the predictions, we make the conclusions about a population using the sample data. In relationship problem, we investigate the correlations. Okay, correlations means between the relationship between the two variables. Number one would be the dependent variable and another would be the independent variable. So in this type, so the type of problem, we would be just only making the conclusions about the relationship of the problems. For example, number one, if determining the average income of a city, for example, if you want to talk about that uh, how much or what we can say how much average students are getting in the biostatistic class, it would be a kind of descriptive problem, because we are talking about the mean, median, average, or mode. If we talk about the predicting the prediction problem or an inferential problem, it would be kind of a predicting election results based on sample surveys. Inferential, it would be inferential. For example, if we take the data in the cities before the elections and we predict who would be the winner of the election, it would be a kind of predicting problem or a kind of inferential problem. If we talk about the relationship problem, analyzing the effect of smoking on lung cancer, it's a kind of relationship problem. In this, simply we are talking about the smoking and the effect of the smoking on the lung cancer. So this is a kind of relational problem. Okay, if we talk about the common challenges in the statistical problem, what are the common challenges? It is the lack of sufficient data or small sample size. Sometimes we take this very insufficient data or a data in a very small sample size. It is a kind of challenge. Sometimes you don't have that much data to take the decision, to predict the decisions, problems about, or to inference the problem. So these are the challenges. And another one is the presence of bias in data collection. Sometimes there is a bias in the data collection. We are unable to take the data on a very logical manner sometimes, and there is a kind of what we can say observational data. Sometimes we observe the things and we just write down. For example, if you are if you see a person, and you can say by your gut feeling that this person is what we can say objected, or this person is included in that type of problem. So number one is the lack of sufficient data or small sample size. Then is the presence of bias in the data collection. In data collection, you can bias the data. Number three is the incorrect choice of the statistical test. For example, you would for if you talk about the taking an average of the salaries, and you do not take the average and you take the mode, it wouldn't give the great results and the proper results. For example, then number four, misinterpretation of results leading to wrong conclusion. Okay, if you misinterpret the results, it can create the wrong results and wrong conclusions. You are unable to interpret the results. You found a problem in an area that was increasing very clearly, and it was very obvious that the problem was increasing, but you predict that the problem is not increasing that much level. So it comes in the problem of misinterpretation of the results, and that would absolutely cause the wrong conclusions. For example, number one, a survey with only 10 people cannot represent an entire city. If you want to predict any conclusion about a city, it wouldn't be a good measure to take the decision on the basis of 10 people. If you would be taking the decision on the basis of 10 people, it will create the wrong conclusions and wrong results or wrong predictions. Number two example would be a bias sample. Sometimes you take the sample on the basis of biasness, only surveying young people about retirement plans. You are taking the surveys of the young people, although you should take the all the people's adults, what we can say, or sorry, young people and mid-age people and old people. You are supposed to take the decision of all these. So you are not supposed to bias the data, bias the sample. Number three would be using a mean when the data has extreme outliers. Okay. Uh, Although we know that when the data is very gathered together, you are supposed to take, you are not supposed, you can take the mean or average. But when the data has a extreme outliers, okay, what is outlier? Outlier means when the data is very beyond the mean value, or when before the, what we can say, in if the data is very centric data in a very measure, so you are taking the data mean in the data when there are the outliers. Outliers are very far from the data, from the old data. For example, if 10 people are there, all the 9 people have the marks in between 10, 5, 9, 6, 7, 8, and only the one person is there whose marks are above 100, sorry, above 90, above 95, above 96. So that one person would be the outlier when the data is very beyond or very away from the result, from the data, from the out all the data. Okay, how hypothesis testing solves statistical problems. Hypothesis testing is involved when you are going to solve any statistical problem. But how the hypothesis testing would solve the problem? It provides a structured approach to decision making based on data. It will provide you the structured approach to make the decisions, and it reduces the uncertainty by testing assumptions with evidence. It will reduce absolute uncertainty because you are testing all the assumptions. You are taking the assumptions with the evidences and with the based on the basis of data and on the basis of all the measures, all the summarizations, etc. Okay, hypothesis testing helps to determine the validity of research claims. Whatever you claim, for example, about any problem, hypothesis testing will determine its validity. For example, if someone says, okay, increasing the income rates of any community will increase the grades of that community. So it would be absolutely helping the hypothesis, all the statistical problems, etc. For example, a company tests if changing store layout increases customer purchases. If you changing the store layout, it may increase the customer purchases. Or because if you will change the look of the store or any shop, people would be attracted over there and they would be happy to purchase from your store because your store is looking very nice and it's very great. So people would be buying from your store. So maybe it would be absolutely increasing the number of purchases or number of sales, but it depends, and you would be testing this all the things in hypothesis testing. Okay, number two, if we talk about the a hospital test, if a new drug a hospital tests if a new drug lowers blood pressure significantly or not. There is a drug and the hospital want to test whether it would be increasing the blood pressure at a significant level or not. This would be a kind of hypothesis testing problem, and it will involve the statistical problem absolutely. Number three, we talk about the a sports coach tests if a new training method improves athlete performance. Sometimes we know that the athletes wouldn't be performing very well in a very predicting or a traditional way, then the coach would try to make the new decisions, to make the what we can say the new methods, or to make new methods of trainings to improve the athlete's performance. It would also be included as a hypothesis testing problem. Okay, if we talk about identifying a statistical problem, so first of all, we have to define the research question clearly. What is the research question exactly? Number two, you are supposed to collect and analyze relevant data. You have defined the problem, you have defined the research question clearly. Now you are supposed to collect and analyze the relevant data, whether the data is unbiased, whether the data is not in the small sizes, and the data isn't that you are applying the good measures of statistical techniques or methods. You are supposed to determine these all the things. Number three, you are supposed to formulate the null and alternative hypothesis. First of all, if you have defined the question, research question, then you will collect and analyze the relevant data. Then number three, you will formulate the null and alternative hypothesis. Okay, what is null hypothesis? Null hypothesis is you are supposed to say you are not supposed to be biased with any claim, free of claims. It is called the null hypothesis. And then alternative hypothesis, that would be absolutely the alternative hypothesis that would claim something changed, that would be for any other problem, for example, for any other solution. Number four, select an appropriate statistical test. After the you have defined or formulate the hypothesis, you are supposed to apply an appropriate statistical test. Whether you are supposed to apply the mean, median, or mode, you are supposed to take that much measure. Number five, conduct the hypothesis testing and interpret the results. At number five, you would conduct the testing of all your claims, and then you will interpret the results. For example, a school tests if male and female students have different average grades or not. For example, if a school is want to test whether uh, it affects whenever a person is female or whenever a person is a male, being a genderistic or being a gender-based decisions, gender-based scenario, whether this will increase the grades or have an effect on grades or not. So this could be the statistical problem, and we can solve this problem by hypothesis testing. Okay, example, for example, analyzing product sales trends problems. If someone want to analyze a product sales trends. Number one, the problem is, does advertising increase product sales? Data is what? The monthly sales before and after the running ads. You would take the monthly sales before the month you are running the ads. The null hypothesis, you will define the null hypothesis. Advertising has no impact on sales. You would define that the advertising does not affect at any measure, at any level on the sales. Then you will define the alternative hypothesis. We talk it about H1 or hypothesis testing one. Advertising increases sales. You would be going with the positive or the negative. Whether you okay, if you are talking about whether it increases the sales or not. Number two, number four or five, we talk about the method. What would be the method? Conduct a t-test comparing pre-aid and post-aid sales data. You would apply the t-test that would be talking about the pre-aid and post-aid. Before the aid, what was the results of the sales? And after the aid, what are the results of the sales? Then we conclude if P is less than 0.05, we talk about the P. What is P? We will be talking in the next lecture. If the P is less than 0.05, we will reject the H naught. It means the null hypothesis is wrong and conclude that advertising is effective. Then we would go that advertising is effective. Okay, if the P is greater than 0.05, if defined is 0.05, then we wouldn't reject the H naught and we would reject the H1, and we talk about that. For example, the H naught or null hypothesis is accepted and the what we can say alternative hypothesis is rejected. Okay, then if we talk about okay, for example, effectiveness of a vaccine. If someone wants to test whether a vaccine is effective or not, what is the problem in this scenario? The problem is that the new vaccine reduces or reduce infection rates. If there is any vaccine, what are the effects of infection rates on that because of that vaccine? So this is a problem. Now, what is the data? Infection rates in vaccinated and unvaccinated groups. You would be taking the data of infection rates in the vaccinated people and unvaccinated people. This would be your data. Then you will define the alternative null hypothesis. What would be that hypothesis? It is the vaccine has no effect on infection rates. This would be your null hypothesis. And if you talk about the what we can say alternative hypothesis, it would be like the vaccine reduces the infection rates, or you can go on the negative side also. You can say the vaccine does not reduce the infection rates. You can also go in the second side also. Okay, what would be the method? We would conduct a chi-square test to compare the two groups because there are the two groups. We would be using chi group, square group testing. This would be studied in the next lecture also. Okay, what would be the conclusion? If the test statistic is significant, we will reject the H naught and conclude vaccine is effectiveness. And if the test statistics are not that much significant, you wouldn't reject the null hypothesis, but you would reject the alternative hypothesis and you would conclude that the vaccine is not effective that much. Okay. For example, if we talk about the analyzing employee productivity, there is a problem. Does working from home increases employee productivity? Is there any, if someone work from the home, would it increase the employee productivity? Would it, he or she would be working in a productive manner or not? The data would be performance scores of employees working in office versus at home. We would take the data of the people who are working from the office and who are working from the home. For example, if I'm teaching from at my home and from my home remotely, you guys are also sitting at your home, and we are taking the class in a manner and in our comfort zone. So whether it would be increasing the performance or not, it would be a kind of statistical problem. Okay, what would be the null hypothesis? Null hypothesis would be there is no difference in the productivity between the work from home and the office employees. You are supposed to take this measure that this would be your null hypothesis, or we talk it as a H naught. What would be the alternative hypothesis? It would be work from home employees are more productive. This would be the null hypothesis, or alternatively, we can also say that work from home employees are not that much more productive. So both sides can be possible. So what would be the method? We perform an ANOVA test. It would be the kind of test we will talk about in the next lecture to compare productivity levels. What would be the productivity levels? This would be our method. Okay, the conclusion would be if a significant test statistic is supports this conclusion, then we will reject the H naught. If it does not support the what we can say statistical methods, then we wouldn't reject the null hypothesis and we would reject the alternative hypothesis, and it will be concluded that the problem or we can say the work from home isn't better that much. To be summarize these all the points, we talked about statistical problems arise when analyzing data for decision making. Okay, then hypothesis testing provides a structured way to validate the conclusions. Hypothesis testing is very necessary during the solution of a statistical problem. Whenever we want to analyze the data, we want to take the decisions. We come across a statistical problem, and we are supposed to take the hypothesis tests over there to validate the results or to validate the conclusions, because the hypothesis testing is a structured way. Then we will try to identify the statistical problems correctly, ensures accurate and meaningful results. We are supposed to identify that much problem. Okay, real world applications. Then we talked about real world applications include the business, healthcare, engineering, and social sciences. These all comes in the statistical problem scenario. Okay, then we can talk about which we discuss about the practice solving a statistical problem to improve research and analytical skills. You can go on with this one also. Okay, so this is all about the statistical problem. Is there any question related to this? Anybody? Is there any question?
No, sir.
Okay, so if we talk about if we jump to our next topic. Okay, then we come